Hello everyone. Thank you for your presence for this conference. I'm very grateful to be able to present to you this talk and I hope that you are all well. I'm going to talk to you about IAM for API security strategy. So let's go. Before, let me introduce myself. My name is Danielle Kayumbi. I have been a software engineer for 13 years. I worked for great companies such as Deezer, Manu, and my own company, DKWave Technology, specialized in student payroll solutions. So let's begin by API. A fundamental element of innovation in today's application-driven world. APIs are everywhere, powering our lives from behind the scenes. Today with APIs, you can listen to music with your favorite application. You can order a cab anywhere, anytime. And we have applications in medicine with nanotechnologies, for instance. The usage of APIs has literally exploded these last few years. According to a recent study, they represent today more than 83% of the web traffic. Yes. However, this rapid growth leads to larger attacks and vulnerabilities. Verizon estimated that 90% of breaches targeted applications and APIs, and Gartner estimated that in 2022 API became the most frequent attack vector. Now I would like to talk about breaches and some famous data breaches. As you know, the Open Worldwide Application Security Project Foundation works to improve the security of software. It identified in 2023 the top 10 API security vulnerabilities. Here I would like to focus on the top one, which is the broken access control. Access control enforces policies such that users cannot act outside of their intended permissions. Failures typically lead to modification or destruction of all data, or performing a business function outside the user's limit. The frequency of API attack will rise considerably by the end of the decade. This leads to damage the reputation of a company. Yes. It's the case of Nissan Leaf with the electric vehicle. An engineer discovered that anyone can control the heating and air conditioning systems of a stranger's Nissan Leaf by sending through a web browser a simple request without being authenticated. Yes, the server didn't verify the owner's identity. It only required a vehicle identification number. No authentication was necessary. It was absolutely crazy and very dangerous. To give you more details, we had a mobile application which exposed some features such as get the status of a battery, the status of a climate, turn off or on the climate in the vehicle, and get details about journeys and distances. And we have insecure APIs, for instance, to get the status of a battery. As you can see, here you don't have any tokens, just a vehicle identification number, and you get all the details. It's the same thing with the air conditioning. An interesting point we have here a simple request which can turn off or on the air conditioning of a remote vehicle, and you have a response with a success status code. That's really crazy. And here, last example, you have a demo where with a simple request you can get the history of the journeys of another user in another country. Fortunately, there was no victim. Nissan closed the mobile application temporarily and deployed a new secure version. It means that security is very important beyond features and functionalities. Another last example, the Pacemaker. A simple denial of service attack has the potential to kill. Yes, it has the potential to kill. 5 years ago, the US Food and Drug Administration recorded 500,000 of pacemakers considered as risk to being hacked. It's very serious. So we have to prioritize API security. APIs are everywhere, but API security is lacking. Each API needs to be understood and protected differently because their usage is unique and their vulnerabilities are also unique. To build our security strategy, we have to answer to this question. What do we need to expose? Who are your users now or in the future, in 1 month, in 1 week, in 1 year? What's the worst thing someone can do with your API? We have to use a strong authentication and authorization solution with a minimum of privileges and limit data exposure. So, what is the solution? We have a solution, and I think you may know. Yes, it's the Identity and Access Management, also called IAM. IAM it's a security discipline that enables the right individuals to access the right resources at the right time for the right reasons. In IAM, we can answer to these questions. Who for identity? Can do what for access? And on which resources for management? Here you have a complete view of IAM components, including single sign-on, authentication workflows, identity federation, and so on. It's very large. In IAM, the components can be classified into 4 major categories: authentication, authorization, user management, and the central user repository. Authentication provides to a user credentials access to an application system. Authorization determines if a user is permitted to access a resource. And the central repository stores and delivers identity information to other services. And in user management, you have the password management, the role group management, and also the user management and so on. All the entities related to identity. By identity, we mean the set of attributes about a user. If I am a bookseller, the relevant information I need about a user is the credit card number or the shipping address. If I'm a tax department of a government, the relevant information I need is the social security number or the physical address. So it depends on the context and the feature delivered by the application. A fundamental principle of IAM is the principle of least privilege. It's a security concept that limits users' access to a minimum level, no more, no less. In this principle, we have three concepts, three main elements. The role-based access control, where users are assigned roles and those roles are associated with specific privileges and permissions. We have the access control list, where permissions are assigned to users for specific resources. We have the discretionary access control, where the owner of a resource decides who can access it. Then I would like to talk about protocols. You know, IAM relies on many protocols. The ones that are a daily occurrence nowadays are OpenID Connect, which is used for signing in with different grants or flows. You have OAuth, the basis of OpenID Connect. You have JSON Web Token. JWT is a standard token format. You have SML for the single sign-on, and other many protocols. With these principles and protocols, before determining our security process, we have to know what is the resource type. Is it an API or something else? What is the source of the identity? The identity, is it external or internal? By external, I mean, for instance, an identity from an external identity provider, such as social media. We have the client types. What is the type of a client? Is it a public client or a confidential client? A public client is an untrusted client. It cannot keep the secrets. So we have to take into account all these elements. To illustrate that, here you have an example of architecture. It's a representation of a marketplace where you have in the backend side two microservices, the cart and the product, and in the front side the single page application and the mobile application. The cart service exposes the one API to get the card by the user ID, and the product microservice exposes one API to get a product by its ID. Both card and product has their own database. Here we can notice that the single page application and the mobile application are the public client, and the card service is a confidential client regarding the request to the product microservice. Public client because they are untrusted parties. Confidential can be trusted to keep secrets. And at the top level you have the authorization server. The authentication flow will depend on the type of the client. For the public client, we can implement the authorization code flow or PXE flow, and for the confidential client, we can implement the client credentials flow. And in the authorization server, we will have a central repository with all the configuration of users, clients, role, and so on. So to illustrate the flow, I would like to show you quickly the workflow of authorization and authentication flow based on OAuth protocol. Here you have four major actors. You have the client, the resource owner, the authorization server, and the resource server. The client asks for authorization on the resource owner in order to access the resources. Then it receives an authorization grant. It's a credential representing the resource owner's authorization. With this grant, it requests the authorization server to get an access token. An access token will contain the role, the scope, the claims, and other special information. With this access token, the client requests the resource server, and in the resource server, we can implement the discretionary access control. Does the resource belong to the user? Does the user has the appropriate role to get the resource? That are the questions to implement the discretionary access control, and if it's okay, the resource server can return the resource to the client. Here you have a detail of the requests in the specific case of a card service. When the card service will get information, will request the product's microservice. Before that, it will get the access token by requesting the authorization server, here implemented with KeyClock, an identity provider. And here we apply the client credential flow. In the request, you can see the grant type, the client ID, the client secret, the audience. We can see that the card microservice has a specific role, product reader, and the authorization server returns the access token. Just a reminder, JWT is technically a mechanism to verify the owner of some JSON data. It's an encoded string and not an encrypted string. It is just serialized. It's very important to note that. So after decoding our access token, we can note in the decoded JSON the custom role provided by the identity provider in realm access node, and in the resource access node you can see the custom role product reader assigned to the client card. With this role, the product microservice can apply the discretionary access control. And that's it. You have many components in each, many frameworks, Spring Boot, Symfony, to implement easily the discretionary access control. You have the principle of router, filters, guard, and so on. So in the different languages, it's very simple. So we see, we have here an example of implementation of workflow of authorization and authentication, and to implement all this process easily, you can use an identity provider which implements IAM, such as KeyClock, which is an open source solution, or Auth0, a solution by Okta. Here I put some example of configuration of a client in Keycloak. We have here the definition of roles, and here we can configure the realm keys, especially the algorithm to generate the access token. Here you have an example with RSA. So to sum up with this solution, IAM especially, we can centralize authentication and authorization. We use protocols and standards, which is very important, and we have a principle of limited privileges to have a minimum level of access to resource by the user. We can go further and add to IAM the zero trust security model. Never trust, always verify. In the zero trust model, it assumes that a breach is inevitable. We have the users, the data, the applications, but we also have the devices and the network traffic where the user is located. It requires validation at every access point of the architecture. Yes. With a zero trust model, we try to understand the who, what, and where of the requests, and once the user is identified, the zero trust architecture evaluates the risk associated with the connection request and inspects the traffic for attacks or sensitive data. And finally, we have a risk score, which is computed for a user, workload, or device to determine whether it's allowed or restricted. It's a complex architecture, and I suggest you to try to implement it if you are facing many attacks. But IAM is enough to build a strong and secure security, best security strategy. Yes. Whatever your strategy, to sum up, I just recommend you to protect your data at all costs. Your users, your reputation, your data depends on that. So please be very careful. It's the end of this talk. I'm very happy. I would like to thank Apidays for this opportunity. I would like to thank you and I hope that I can see you at the next conference. So enjoy all the talks and take care. Bye bye. Have a nice day.